Good morning, fifth grade. Wanted to jump on and help explain to you packet page 17. This is Punnett Square practice. Before we get started, you obviously need your packet page, but then also I find it really helpful to have two different colors to use to help you as you're going through and practicing creating Punnett squares. So it can be a pencil and some sort of other color, colored pencil, crayon, anything, or like a highlighter if you want. But I just think that's really helpful in creating this to help it make sense. I wanted to just review two quick things before we get started. First, you're gonna, in these two scenarios, you're going to hear the terms heterozygous and you're going to hear the term homozygous. So a heterozygous means you get one from each allele, okay? So when we're talking about genes that are being passed down, you're going to get one allele or gene from the mom. You're going to get one allele or gene from the dad. Okay, so if you're heterozygous, it means that you have one that's dominant and one that's recessive, right? See, there's one of each. If you're homozygous, same thing, you're still getting one allele from your mom, one allele from your dad. However, these alleles are the same. So they can be two dominant or they can be two recessive, okay? So just kind of keeping that in mind as we're going through it. The other thing we're gonna talk about is this notion of this idea of probability. So probability means what is the likelihood that it's going to happen. So as we create and do Punnett squares, what we're looking at is how likely is it for this particular trait to show up. So in doing so, when we think about these, the square itself represents 100. Okay, so I drew this like very rudimentary drawing to help you understand. But the square totally equals 100. Okay, so in this first square, you have a 25% chance of getting whatever this combination is. Whatever this combination is 25%, 25 and 25, obviously that added up to be 100. Now, if some of these are the same, you could say I have a 75% chance if these three are the same for this particular allele. We'll talk through that, but just so you know, your answers for probability are always going to be, with a Punnett square, 25, 50, 75, 100, or 0. Okay, let's get started. Okay, what is the probability that a heterozygous brown-haired man, now this one, they went ahead and gave you the allele combination. Notice they said heterozygous, and checking in, we know that's one of each, and here we have one of each. So I'm gonna put that one right here. I'm gonna put a capital B here and a lowercase b here, because here are the two alleles that they had. And a blonde woman, lowercase b, so I'm gonna put that one right here, okay? Would have a blonde child. So I'm looking for the percentage of blonde, okay? Now I know that blonde is going to be lowercase b, so that's what I'm looking for. What's the percentage? Okay, here is how we do Punnett squares. Anything that's up here on the top gets brought down. Okay, you just bring these straight down. Anything that's on the side gets brought straight across. Now you may go, Mrs. Phelps, I noticed that you put some on the front and some on the back. Does it matter? It does not, okay? It's like an addition fact in that if you write 2 plus 3, it's the same thing as 3 plus 2. However, in the scientific community, you want to include the capital letter first, just because obviously that's the dominant trait. And so that's the way that you kind of want to handle that. So you might see me move it to one side or the other just so that it's capital on the left-hand side, but it does not technically matter in terms of what the actual allele combination is. Okay, so we've done our Punnett square. We've got our 4 choices that it's going to have. We're looking for, remember, lowercase b, lowercase b. Lowercase b is here. So we know we've got a 25-50% chance that it's going to be blonde. So far, so good? All right, let's look at this next one. The probability of 2 heterozygous brown-eyed parents, okay, and again, luckily they gave it to us here, of having a blue-eyed baby. So we want to know the percentage of the blue-eyed baby. Okay, now here's where it gets a little tricky. We know we have these 2 letters as our two alleles. We know that if it shows up, this is what they have, but if it shows up as brown-eyed, we know, like physically, if you're looking at someone and they have brown eyes, we know that whatever this capital letter is going to be what's dominant and what you see. So I can deduce that the capital B stands for brown-eyed, right? Because if I look at this person, that's what they have. However, they also have this blue-eyed gene, okay? So same thing. One parent has capital B lowercase b. The other parent has capital B lowercase b. And same thing. These are just going to go straight across. These are going to come straight down. And then we're going to use it. So I have one chance of having brown-eyed, one chance of having brown-eyed, one chance of having brown-eyed, which means 25, 50, 75% chance that it's going to be brown-eyed. But that's not the question. That's not what the question's asking. The question's asking for blue-eyed, right? So we have this 25% chance that their baby is going to have blue eyes. So far, so good? All right, let's jump over and keep going. This one is asking you to list genotypes and phenotypes on top of your Punnett square, okay? So remember, just to refresh, the genotype is the letters and the phenotype is the physical appearance, okay? So we say, list the genotypes and phenotypes of a homozygous, dominant, curly-haired mother. Okay, so let's think about it. Remember, homozygous means two alleles that are the same. And because it says dominant, we know that's going to be a capital letter, okay? And when we physically look at this mom, she has curly hair. So we know it's going to be capital H, right? So we know that capital H is going to stand for curly hair, right? Again, she's got two of the same. It's dominant, so we know it's got to be capital letters. And if we look at it, she has the curly hair. So we know that the capital H must be curly hair, okay? So we can then deduce that lowercase h is going to be straight hair. All right, let's look and see what the dad brings. And a straight-haired father, okay? So he has straight hair. So that means it's lowercase h. Now remember, with a lowercase letter, because it's recessive, it has to be two lowercase letters for it to work. Okay, so let's pull those across and down and see what we got. So these again are just going to come straight down. These are going to go straight across. And here are combinations. When we look at this, our genotypes we actually just have one possible combination that it could be, right? However, when we look at the phenotypes, what phenotypes do we have? And all of these, because they all have this capital letter, this child is going to have curly hair. Okay, so far so good? All right, we got one last one. You guys are doing great. List the possible geno and phenotypes if a purebred father. Okay, so here's the thing. Purebred is another word for homozygous, okay? If you have pets and you have a purebred dog, that means we have a purebred, we have a Shih Tzu dog. So we have the dog that we have, the mom and the dad were both Shih Tzus, right? And so they both passed on their traits to their son, to Mickey, and he is purebred, right? We have another dog who had a mom that was a Yorkie and a dad that was a poodle. So that one would be heterozygous because they got one set of genes from the poodle and one set of genes from the Yorkie. Okay, so just in case you see that, it also means homozygous. So here we go. Okay, list the possible geno and phenotypes if a purebred blue-eyed father and a heterozygous brown-eyed mother had a child. Use B. Okay, so we know that one of these, we're talking about eye color. We know that a purebred blue-eyed father and a heterozygous brown-eyed mother had a child. Okay, Well, we know, we can deduce. Let's start with this, the heterozygous one, because I think that'll be easier. Okay, so if it's heterozygous, that means they have one of both, right? So that means this one has to be big B, little b, right, if we're using B. And it shows up as brown, right? This mom has brown eyes. So we know because this has a capital letter, that's the dominant letter. So we have brown eyes and we have blue eyes, okay? So the mom is going to be capital B, lowercase b, right? Because she's got brown eyes. Let's look at the dad. Purebred, so we know that's homozygous, blue-eyed, okay? Blue-eyed we deduced was this lowercase b. So we know he is going to be lowercase b, lowercase b. So far, so good. We're going to take these across. We're going to take these down to have our choices. Okay, so let's look at the genotypes. So we have big B, little b, right? Capital B, lowercase b. And we actually have that as 50%, right? We have a 50% of having that. And we have lowercase b, and we have a 50% chance of that. Because remember, these are each 25. So 25, 50% chance of this, 25, 50% chance of this. If I look at the phenotypes, the capital B, lowercase b, if I physically look at them, this dominant gene is going to show. So they could have brown eyes. Or if these come to play, we have lowercase b, they could also have blue eyes. Questions, reach out to your home teacher or send me an email and we'll talk it through. Have a great day.